Dear children, today we are going to discuss the topic vectors or vector analysis. You might be knowing that while discussing the concept of the physical quantity, we come across the terms. Number one is the derived physical quantity and second one is the fundamental physical quantity. That is the first classification of the physical quantity. Secondly, we can classify the physical quantities as scalars, and number second is vectors. You might have read in earlier classes about the scalar. Now, scalars are those physical quantities which are characterized by or described by magnitudes only. Magnitudes only. Now, in case of scalar, there is no concept of direction, and one more important point is that scalars can be added, subtracted, multiplied and divided by using the simple laws of algebra. Simple laws of algebra. Simple laws of algebra. But the vectors are those physical quantities which are characterized by magnitude, number second is direction, and number third, obey the laws of vectors. Vectors may be defined as those physical quantities which have magnitude, direction, and in addition to the magnitude and direction, the vectors obey the special laws which are known as the laws of vectors. Now, for example, we talk of force, we talk of velocity, we talk of acceleration, etc. All these physical quantities are the examples of the vectors, because all these physical quantities are characterized by both magnitude, direction, and in addition to these two, these physical quantities obey the laws of the vectors. Now, this is a simple definition of the vector. Now, the question is how to represent the vector. Representation of a vector. Representation of the vector. How to represent the vector? Now, vectors are usually represented by straight line with arrowhead over it. Arrowhead over it. Vectors are represented by means of the straight lines with arrowhead over it, or simply we can write vectors are represented by the arrowed lines. Arrowed lines. Now see, let me draw the straight line with arrowhead over it. Now this is how to represent the vector. Now let me name this as point O and this as point A. Now point O is called tail, while as the finishing point of the vector is known as tip. We can call tail as the origin and this tip as the finishing point. Now the length of this O is the starting point of the vector, whereas A is the finishing point of the vector. Now the length of this arrowed line from O to A, length of this arrowed line represents the magnitude, length of the vector. Length of this arrowed line length of the arrowed line this is called the magnitude of a vector, and this arrowhead over it specifies the direction of a vector. Now this magnitude of a vector or the length of the vector is mathematically represented by this. And this is read as modulus of vector OA. This is the mathematical representation for the magnitude size of the vector. This is read as modulus of vector OA. Now, for example, if we have the force F is equal to 2 Newton due north, the magnitude of this force, which can be represented by modulus of F, is 2 Newton. And the direction of this force is due towards north. Now this is how to represent a vector. Now some important terms some important definitions. Number 1, equal vectors. Now let me draw the two vectors. Let me name this vector as vector A and this is vector B. As we see from the diagram, both the vectors have the same magnitude and both the vectors are acting in the same direction. Then we call these two vectors, that is A and B, as equal vectors. Now, two vectors are said to be equal if they have same magnitude and have the same direction. Same magnitude and same direction. Same magnitude and same direction. For example, the two boys are moving along a same straight line, or we can say that the two boys are moving due north, and both the boys have covered the same distance or displacement, that is 2 meters. Magnitude is same and both the boys are moving due north. Therefore, that can be taken as the example of the equal vectors. Now, number second, negative vectors. First of all, let me draw the diagram. Let this be vector A, and let me draw another vector. We call this as B. As you see from the diagram, both the vectors have the same magnitude, but both the vectors are oppositively directed. Opposite directions. Now, these two vectors A and B are said to be negative vectors. A is said to be negative of B, or B is said to be negative of A. Here we can write B is equal to minus times A. The only difference is the directions are opposite, but the magnitudes are same. Therefore, we can now conclude that the two vectors are said to be negative if they have same magnitude but opposite directions. Opposite directions. Here, same magnitude and same direction in case of the equal vectors, but here same magnitude but opposite directions. Number third is unit vector. Unit vector. Now, a unit vector is that vector, the unit vector of a given vector is that vector whose magnitude is 1 and direction same as that of given vector. Simple definition. Magnitude 1 and direction same as that of given vector. Now, this is the simple definition. Magnitude same and direction same as that of given vector. Now, let me take an example of the vector A. This is vector A. If we need to write its magnitude, we write its magnitude as magnitude of vector A. We write this as modulus of A. But unit vector is associated with each and every vector and is having the same direction as that of given vector. Now the question is, how to represent this unit vector. Suppose we talk of vector A, its magnitude is represented by modulus of A, written as like this. Now, unit vector of A, unit vector of A is written as, and this is read as A cap, or A hat, A cap or A hat. This is how to represent the unit vector of vector A. Now, we can write vector A equals modulus of A, and we need to associate on this side the vector having magnitude 1 and the direction same as that of the given vector A. Therefore, we need to write here A cap. Now, this A cap is having the magnitude 1, but direction is same as that of given vector A. Therefore, from this equation, we can write A cap is equal to vector A divided by magnitude of vector A. Therefore, we can write unit vector is equal to given vector divided by magnitude of given vector. This is the another definition of the unit vector. Here we define this as the vector of magnitude 1 and direction same as that of given vector. Another way, another definition, unit vector of a given vector is defined as a ratio of given vector to the magnitude of the given vector. Now, if we talk of the rectangular Cartesian coordinate system, we have three different axes. This is x, and this is y, and this is z axis. This is the origin. All the three axes are mutually perpendicular to each other. That's x, y, and z, like this. Now see, the unit vector along x axis is I cap. Unit vector along y axis is j cap. J cap. And the unit vector along z axis is k cap. Since all the three axes, that is x, y, and z, are mutually perpendicular to each other, therefore these three unit vectors, that's I cap, j cap, and k cap, are mutually perpendicular to each other. We call these unit vectors mutually orthogonal unit vectors. Since these axes are mutually perpendicular to each other, therefore these three unit vectors, that is I cap, j cap, and k cap, are mutually perpendicular to each other. Therefore, we call this as mutually orthogonal unit vectors. Another point regarding the unit vectors is that it being the ratio of the vector, given vector, to the magnitude. Therefore, unit vector is having no units and no dimensions. No units and no dimensions. Now let me take an example how to find the unit vector of a given vector. You can write the question as find the unit vector in the direction of A equals to I cap minus j cap plus 3k cap. Now let me evaluate this question. I will simply write A equals to I cap minus j cap and plus 3 cap. Since, as obvious from this equation, this vector A is having three components: x component, which is 2i, y component, which is j, and z component, which is k. Well, this vector is having three components: x component, y component, and z component. Now, in order to find the unit vector of vector A, we need to find the magnitude. Now, how to find the magnitude? We write magnitude of A as modulus of A, and this is equivalent to, you must remember this equation. Now, the coefficient of I is here 2, I will write under root of 2 square, then plus the coefficient of j cap, this is 1 rather than minus 1, we will write this as minus 1 square, then plus the coefficient of k, which is 3. I can write this as 3 square. Now this means to find the magnitude of the given vector, we write this as mod of A equals under root of coefficient of I ka square plus coefficient of j ka square and coefficient of k square. And we write this as, this is 4 plus 1 plus 9. On simplifying, we can write this as under root of 14. Therefore, A cap is equal to given vector divided by the magnitude of that vector. Now, vector A is 2i minus j cap plus 3k cap divided by magnitude of A, that is under root of 40, and this is the required answer. This is simply how to find the unit vector of a given vector. Now let me take the another term, which is co-initial vectors. Co-initial vectors. Vectors are said to be co-initial if they have same common initial point. Same common initial point. And we can draw the diagram as this is vector A, vector B, C, and D. All the vectors have the same common initial point, that is O. Therefore, we call these vectors as co-initial vectors. Vectors are said to be co-initial if they have the same common initial point. Now, another topic, position and displacement vector. Position and displacement vector. Let me first discuss the position vector. Consider the particle, the motion of a particle in xy plane. This x-axis and y-axis, this being the origin, xy plane. At any instant, particle is moving in xy plane. At any instant, t equals t1. The particle is at point P. Let me mark this as point P. This is the position of the particle in xy plane at an instant t equals t1. Now, if we draw an arrowed line starting from the origin and finishing at this point P, then this arrowed line, which I have drawn from point O to point P, is known as the position vector. OP is known as the position vector. A particle at an instant t equals t1. Therefore, I can simply write OP is equal to position vector of particle at instant t equals t1. Now, at another instant, let me take the particle has reached here. T equals t2. Particle is at point Q. Therefore, we can draw another arrowed line starting from the point P and finishing at point Q. We can call this OQ as the position vector of the particle at instant t equals t2. Now, this position vector of a particle, it gives us two important informations. Now, in simple words, the position vector gives the position of the particle with respect to the origin. This OP gives me the position with respect to origin. Similarly, OQ gives the position of the particle at t equals t2 with respect to O. Now, this position vector of a particle at a given instant provides us two informations. Number one, it gives the straight line distance of particle with respect to origin. This is the number one information. That is, the position vector of a particle gives us the straight line distance of the particle with respect to origin. The origin here is O, and second, it gives the direction of position of particle. Direction of position of particle, again with respect to origin O. See the direction of the position vector OP and see the direction of the position vector OQ. Both are different directions. They are making different angles. Now this is all about the position vector. Number second is the displacement vector. Displacement vector. See, the next x is y. This be the origin. This is at t equals t1. The particles are at point P. And we can write OP equals R1, usually position vector representation, which I forgot it writing the previous. And let me draw another arrowed line. OQ at t equals t2. This is at t equals t1 and this is at t equals t2. And we may write OQ equals R2. This R2. Now both OP equals R1 and OQ equals R2 represents the position vectors of the particle at different instants t equals t1 and t equals t2 with respect to origin. In order to define the displacement vector, let me draw the arrowed line starting from Q and finishing at P. Then this arrowed line QP is known as displacement vector of a particle in time interval T2 minus T1. T2 minus T1. Now, if we will use the triangle of vectors here, which I will discuss in the second lecture, you may simply remember this now. We can write in triangle OPQ. A leave which we will discuss in another lecture. We had confusion. This is the concept of the displacement vector. This is all about the today's lecture, that is the introduction to the vectors.